Hello engineers, welcome to another video on low level design. In this video we'll look at the visitor pattern. I hope you're ready. Let's get started. So this is the intent. Represent an operation to be performed on the elements of an object structure. Visitor lets you define a new operation without changing the classes of the elements on which it operates, right? So let's try to understand this with an example. This is a very interesting pattern. Let's say we have different types of users defined in a beautiful class structure like this. So let's say we have a user class like this, which is being extended by the guest user class and the registered user class, right? So these are my user types, guest and registered, and this is neatly following the single responsibility principle because all user related operations are here and guest related operations go on here, registered users operations go on here, and this is also extendable to a different type of user. So this is also following the open close principle. But the challenge comes when we want to add new features to this structure. So let's say we want to send different types of newsletters to different types of users. So guest users will receive different types of newsletter emails, registered users will get different types of registered newsletter emails, right? So how do we do this? So one way to do this is add to this class, send email, add to this class, send email. So internally they will have their own operation to send respective emails to guest user and registered user, right? So that is one way to do it. So that is one feature. Let's say I want to add more features. Let's say I want to add audits to these users. So guest users will undergo different type of audits, registered users will undergo different type of audits. So again, I can add new method here, audit here, audit here. But very soon you will realize that we are no longer following the single responsibility principle because these classes are changing for every new operation, right? We are going to this class and add a new function and add the respective implementation and so on, right? So this is something we don't want to do. We want to keep our user structure intact and we want to keep our new features or new operations separate from the structure, but we still want to do the operations on each type of user, each type of object, but we don't want to come back to these classes and change these classes so that every time there is a new feature, I don't want to come here and update these classes. So how do we do this? So that's where the visitor pattern comes in. So using the visitor pattern, we can achieve it like this. So this is how the new structure will look like. The same user guest registered class structure is retained, and we are just adding one more method called accept, which will accept an object called v. V is nothing but a visitor. So what will this method do? So this method will call an internal function of the visitor like this, v.guestUser. And this will call v.registeredUser. Right? So by doing this, we are able to define the class structure once, which will always accept a new type of visitor and call the internal method. This will accept a different type of visitor and call registered method. So this operation is not changing. We are always calling v.guest. We are always calling v.registered here. But the type of object can change. The visitor object can change. So what will the visitor look like? Let's have a look. So this is how the visitor class will look like. So it is a simple interface which can be implemented by different types of new operations. So the first operation which we discussed was sending newsletters. And this will expose two methods, one for guest and one for registered, right? So when we send this newsletter object into the guest class like this, when we call v.guest, so which is invoking this method. So this method will know what to do with the guest user, how to send emails to the guest user. Similarly, when we send the newsletter object to this guy, to the registered class, internally, this is calling v.registered, which is this method, and this method will know what to do with the registered user, right? So this way we are able to create an operation separate from the main structure. So instead of invoking the first method like this, send email, we are doing it in two steps. First, we are accepting a visitor, and then we are calling guest, which will internally trigger the email notification. We are accepting a visitor, we are calling v.registered, which will internally trigger the newsletters for the registered user, right? So this system is called double dispatch. So why are we doing all this? What is the advantage we are getting? We are able to retain the original structure. We don't need to change the structure for any new feature. So this is the first feature. Let's say I'm adding a second feature for audits. So let's say this is my audit class. This is also implementing the visitor pattern, and this is also exposing two methods, one for guest, one for registered user. So I can send in this audit object into the accept method here, and internally this will call again v.guest, which will just trigger this method. This knows how to do the audit for the guest user. Similarly, if we can send the audit object into the registered accept method, this will again trigger v.registered, which will be triggering this method, and this method knows how to handle audits for the registered user, right? So I have just added two more features, but I have not disturbed the structure of the user system, user guest registered structure, right? So this way we can add any number of features like this. By just using the concept of method overload, we are using the same name, guest registered, guest registered, guest registered everywhere. And we are able to invoke different types of operations for different types of users without actually having to know about them, right? So this structure does not know who the visitor is and what they are doing. They are just accepting a visitor and calling their respective function. Registered user is accepting a common visitor and it is triggering the registered method. This way we can add any number of features. So this is the advantage of this visitor pattern. So we are able to decouple the new operations from the main structure so that we can add more number of operations, right? So this is one example. Let's try to understand this with another example called abstract syntax trees. So this is something which is used in compilers. So let's say we have a programming language compiler which is evaluating this type of expression. So if you observe it closely, there are a bunch of operations here. First is a subtraction operation between two numbers, and then we have an addition operation between two numbers, right? So if we build an abstract syntax tree for this, it might look something like this. First, we have the add expression, which is holding 10 on one side and which is holding 5 minus 3 on one side. But again, this can be expanded into a subtract expression, which will hold 5 on one side and 3 on the other side, right? So this is how the tree can grow in any form. So this tree can be expanded to different things in a programming language for a if condition, while condition, and for loops, etc. So that is how the compiler checks for different types of expressions, right? So for a compiler, these things are fixed. How to evaluate add, how to evaluate subtract, how to evaluate if condition, how to evaluate for loop, right? And so on. So this structure is fixed. And I want to perform some operations on this structure. Maybe I want to do type checking. If I'm using something like TypeScript or C++, I want to do whether all the types are good or not. Maybe I want to print them. Different expressions require different types of printing. So, and also maybe I want to do variable evaluation. I want to check whether one variable is declared before use and things like that, right? There can be a bunch of things that I can do with a compiler, but I don't want to disturb this structure. I want to add all these features. Maybe there will be new features coming up in the future. I don't want to disturb this structure of the programming language features. So these are fixed, these are static, but these are dynamic. There can be new features coming and going. So in these type of situations as well, I can declare visitors for each of these types. These can be visitors which are coming into each of these classes, and they can be used as visitors, just like how we did for the users. They will come in as visitors, they will call their internal respective functions and keep their structure intact, right? This is also one of the main uses of the visitor pattern. So wherever we have a stable structure like this and we don't want to disturb the structure but want to add new features, we can make use of the visitor pattern. Now let's see how the pattern is actually implemented. Let's go to UML now. So this is the class diagram representation of the visitor pattern. So on the left side, we have element, which is a common abstract class, which is being implemented by element A, element B, right? So these are nothing but our user types. So element is our user, and we have guest user here and registered user here. They will expose a method called accept, which will take in a visitor object. And what will this function do? This function will take the object and call the respective function of this class. So here we are calling visit element A, and here we are calling visit element B, right? So by doing this, we are able to keep this structure intact. This structure will remain the same, and operations can keep on coming to this method and they can execute on their own. So how will this visitor class look like? It looks like this. So visitor is a common interface which is exposing two methods, visit element A, visit element B. And this is implemented by different types of visitors. And each of them will expose these methods because they are implementing the common interface, and they will have visit element A, visit element B as part of their exposed methods. So when we pass visitor A object into this method, we are invoking visit element A of this one, which is nothing but a double dispatch. Similarly, if visitor B object is passed on to element B class, it will trigger visit element B method, which is this one, and then this method will know how to handle it. So this is how the visitor pattern is structured, right? Now let's see the sequence. So the sequence is quite simple. It's a simple concept of double dispatch. Instead of directly invoking the visit element function, first we will send the visitor to the element using the accept method, and inside that method we will call the function. And that function will know what to do with this because we are also passing the reference to this object using the this keyword, right? So that's how the sequence goes. So now let's take an example of the users and features that we have been discussing. So on the left side, we have the structure user, guest user, and registered user. So we want to keep this structure intact, and we will expose a method called accept from each of these classes. And each of these methods will accept a visitor object. And within this method, we will simply call the respective function of this class. So this function is calling visit guest user. This function is calling visit registered user as part of this object, right? So we want to retain this structure. Because we have exposed the accept method, this can accept any type of visitor and call its respective function, right? So how do we use this? So we have the visitor interface, which will be implemented by different types of features. For example, we want to send newsletters. We will have two methods, visit guest user, visit registered user. And when we pass the newsletter visitor to this guy, we will invoke the visit guest user method, which is nothing but this one. And this method will know how to handle newsletters for guest users. This method will know how to handle newsletters for registered users, right? So this way I'm able to decouple the operations from my main structure, right? And similarly, if I want to do audits, I will send the audit visitor to these guys, and each of them will call their respective functions. Visit guest user will do audit for guest users. Visit registered user will do audits for registered users. So by just using a simple concept of method overloading, we are able to achieve quite a good flexibility for adding new features without having to disturb the main structure, right? So this is the class diagram for this implementation. Now let's see this in code now. So I'm in VS Code now, and we have a new file visitor.cpp. So let's try to understand the visitors. So visitor interface has two methods, visit guest user, visit registered user, and these will be implemented by the newsletter class and the audit class. Now let's see the base user class as well. So the user class will only have one method called accept, which will accept a visitor, right? And this will be used in two classes, guest user and registered user. So as we discussed, the accept method will accept a visitor and just call the respective function of this class. So the function is visit guest user for this, and the function is visit registered user for this, right? That is the implementation. And let's see the visitors now. So the newsletters class will have two methods, visit guest user, visit registered user. So this will be responsible for handling guest newsletters. This will be responsible for handling registered users newsletters, some kind of personalized newsletters. And then the audit class will do something similar, which will also have two methods, visit guest user, visit registered user. And this is doing logging of guest user activity. Here we are doing auditing of the registered user, right? So this is how the structure is. Now let's see the usage. So we have created two objects, one for guest, one for registered user with my name. And then we have created two visitors, newsletter visitor and audit visitor. These are our two new features, right? And then we are passing in the visitors to each of these classes. So we are sending the newsletter visitor to guest. We are sending the newsletter visitor to registered object. Similarly, we are sending the audit visitors, right? So without disturbing the guest and registered user classes, we are able to add new features and use them in a very efficient way, right? So let's run this and see. So as you can see here, we are able to send guest newsletters and personalized newsletters. We are able to do audit operation on both types of users, right? So this is a code implementation of the visitor pattern. Now let's see some trade-offs. So with the visitor pattern, we are able to follow the open close principle quite well, because we are able to add any type of visitor as required without having to disturb the original structure. And we are also able to group related operations into a visitor class so that they can be invoked without having to disturb the original structure, right? So these are the strengths. And then coming to weaknesses, because we are sending the object itself to the visitor, using this keyword, the internal details of these objects are exposed to the visitors, right? So that is something to keep in mind. And another weakness is new element types need change in all visitors. For example, if there is a third user type apart from guest user and registered user, let's say there is a third user type, let's say subscribed user. So all the visitors need to change now. There should be a new method for visit subscribed user everywhere, right? So that is an overhead that we need to take into consideration while using the visitor pattern. Okay, that's it for this video, guys. We have seen the intent, we have seen the example use cases, we have seen the UML diagrams, the code walkthrough, and also some trade-offs. So if you have any questions or suggestions or inputs, definitely put them in the comment below. Please leave a like if you found this helpful. Please subscribe to the channel so that you don't miss out on any future videos. Thank you so much for watching. I will see you in the next one. Cheers.